it is mentioned that it has an angle of 30 degree, 20 degree. So, and two blocks are placed like this, right? So they are asking you to identify what is the tension and what is the velocity of the body, right? Again, you can solve this in three different methods, right? So as we discussed earlier, so we can go for D'Alembert's principle, we can go for work energy method, and also impulse momentum method, right? So all the three methods you can able to solve this problem. But the thing is, so the movement, so movement is the problem here, right? So if you consider the movement of an object, it you can classify the movement in two category based on inclination, right, and based on weight of the object, right? So if I consider inclination, if you have greater inclination, if your angle is greater, if your angle theta is greater, there is a lots of possibility to have a slide along the direction. If I consider here, one is 30 degree, other is 20 degree. So there is a possibility of more slide on this 30 degrees, which means that I can say that this block will move like this instead of like this, right? Hope you can understand, because the angle is more, which means this will intend to move along this direction rather than this direction. Okay, so that is one thing. The other one is weight, right? If I consider if there is an increase in weight, of course, increase in weight will tend to move along the direction. Okay, so this problem, if you look at this problem, both are in same direction, same side. So I think it is not at all a problem here. You can easily solve this. One is 10 kg higher when compared to this 6 kg, and angle is also higher. Both are higher. Since both the values are higher, I know that this block will move along this direction. Easily I can identify, right? So you can easily identify that the block will be moving along this direction. If this block is moving along this direction, what about this block? This block will be moving like this. Okay, so here comes that problem. So what happens, right, if there is a change? For example, this one, let me consider that instead of 10 degree here, 10 kg here, let me consider you have 5 kg here. And instead of 6 kg here, let me consider 15 kg or 20 kg or 25 kg here. So you can see that there is a difference here. So angle is on this side, which will tend to move along this direction. Weight is on the other side. So because of the weight, there is a possibility that the object will move along this direction. That is also possible, right? So in that case, what you have to do is you have to guess, right? You have to guess any one direction, right? That problem, if you are lucky, you can complete it in one step. If it is not so, you have to repeat it again by changing direction. Okay, so the thing is, I will guess that your object is moving like this. So if this object is moving like this object is moving like this. So what I can do, I can able to solve the problem. When I solve, you have to look after the tension value, right? If the tension value is negative, if the tension value is negative, right, it means that you have chosen a wrong direction, right? You have chosen a wrong direction. So it's a wrong direction. So at the moment you get the different tension, you have to write a step that since the tension cannot be a negative, so the assumed direction is wrong. Considering opposite direction, you have to write it like that, and then you change the direction. Okay, so this is applicable if there is difference. So one side you have higher inclination, other side you have higher weight, right, which will be a different category. We don't know which side the block will move, right? That type, then you have to consider this. You assume one direction. If you get tension values and the other values positive, no need to worry, you can directly solve it and you can stop. If you get a negative, which means again you have to redo the problem by changing the direction, right? In this case, I think there is no problem at all, because both weight as well as the inclination is on same direction. So I surely know that this block will be moving along this direction. In that case, this block will be moving along this direction. Okay, so we can easily solve it. We can go for D'Alembert's principle and we can proceed accordingly, right? So you have to draw this block, right? So first, let me go for block A. If I consider block A, so this is my block, right? This is my block. So this block is having a tensile force T, right? So if I consider this as, let me consider this as A and this as B, right? So this is BTAB. This angle of this TAB, so this is parallel to this inclination. So the inclination is 30° with respect to x-axis, right? So which means this is also 30° with respect to x-axis, right? And you have weight, so weight of the object which is acting downward. So 10 kg, so which means 10 into 9.81, so 98.1 Newton. And then you have a contact here, so which means you have a reaction. You have a reaction R, right? So reaction is perpendicular to this. So if this is angle 30° with respect to x-axis, this will be with respect to y-axis. This will be with respect to y-axis. Okay. So these are my overall diagram. Okay. So for block A. So if we consider block B, right? So you can able to see that this block is something like this, right? So when I consider here, you have tensile force TAB, which is acting towards this direction, and the angle is 20°. The angle is 20° with respect to horizontal. Then you have weight, which is acting downward, which is 6 kg. So 6 into 9.81. So that will be the value for this side. So what will be the value here? 6 into 9.81, 58.86 Newton, right? Then you have a reaction. So this is a contact surface. So you have a reaction here. The reaction is RB. Oh, this is RE, right? RB, and the angle of this is vertically 20°, right? This is my overall values, right? So now I can go for the principle. One by one, we can solve one by one. So let me go for Newton's law, D'Alembert's principle. Right? This is my thing. So when you look here, right, you can solve by two possibility, right? By considering the x-axis as the same, and you can solve it, or by changing your x-axis, right? By changing the x-axis also you can do that, right? That also possible. So according to D'Alembert's principle, so you know that there will be another force, so which is opposite to the direction of motion. So the direction of motion is this direction. So opposite to this, you have a force which is parallel to TAB, right? So it is mass into acceleration. 10 into AA is my force, right? So of course, if this is 30° inclination, this is also 30° inclination, right? So usual way is you can draw what you can say, your axis, and you can mark everything and you can resolve it. That is one way. The other way is there is another simple way. So what you can do is you can change the axis, right? I am going to do it like that. So which means what I'm going to do is, so you can able to see most of them are 30°, 30°, 30°. So what I am going to do is I'm going to consider this one and this one, right? I will consider parallel to these things as x and y axis. Okay. So when I do like that, so your resolution of forces will be lesser because you can neglect this 330 degrees. because it is parallel to x-axis and parallel to y-axis, right? So only one is with a 98.1. That alone you have to identify what will be the angle, and that alone you have to mark it out, right? That alone you have to mark it out, and you have to uh, find out what is the inclination. So you can resolve it, right? So this will reduce your work, right? Actually, this will reduce your work instead of going directly. So if I consider this as x and y, what happens? RA, I have to put RA cos theta, RA sin theta. Similarly, TAB, RA, TAB cos theta sin theta, and 10 AA also cos theta sin theta. So you can able to get lots of cos theta sin theta, and uh, solving it somewhat, it will be somewhat complicated, right? So this one will simplify that work, right? So what I can do, I can consider this my axis, right? So let me denote what are the values accordingly one by one. So see that x-axis is along this direction, so which means this one is TAB plus, so parallel to that, so which is 10 into AA. So both are having in this direction, and RA is moving upward, so this will be my RA, right? So parallel to your y-axis, and you have this 98.1. So which quadrant? It is in third quadrant, right? So you have this 98.1. So my question is whether this is 30 degree or this is 30 degree. So the angle 30 degree is here, right? So I got it. Okay. So now I can say that sigma fx is equal to 0, right? If I say sigma fx is 0, so TAB plus 10 AA minus 98.1 sine 30. So bringing to x-axis where angle is increasing. So sine 30 is equal to 0, right? Which means I will get an equation TAB plus 10 AA is equal to, so 98.1 sine 30. So you know that sine 30 is 1 by 2, right? Which means 98.1 divided by 2. So 49.05. So this is my equation 1, right? So next I will go for sigma Fy is equal to 0, right? So when I consider sigma Fy as 0, right? If I consider sigma Fy as 0, so you know that Ra minus 98.1 cos 30. So that is equal to 0, which means I will get what is my Ra, right? So Ra is 98.1 into cos 30, 84.957 Newton, right? So this is my value, right? Any doubt in this part? I think there is no use in identifying this thing, but anyway, so if you have a friction, you have this thing, you will have this thing to identify. Other than this, there is no use of identifying Ra because we are not going to use anywhere, right? If you have friction mu into Ra, we will substitute it. In this case, there is no possibility, so you can just directly mention it. That's it. Okay, now we will proceed with the next one. So your B. So here also I'm going to follow the same thing. So I'm going to consider this one as x-axis and this one, right? So whatever it is going like this. So this is my y-axis, right? So let me put what is my quadrant here. So this is my axis quadrant. Now I will denote it one by one. So TAB. So it is directly going like this upward direction. So TAB, right? And RB. So it is along your x direction, RB, right? And you have this 58.1 in second quadrant. So 58.86. So again, right? So this RB is vertically 20 degree, right? So which means this is 20 degree, right? So now we can proceed similarly. So let me go for sigma fx. I think as I told you, so you can simplify the work. So if you look here, Fx will have RB. I don't want RB, right? I want only relation between TAB. Okay, I missed one force, right? I missed one force, which is your mass and acceleration. So the object is moving upward. So this object is moving upward. In this case, you will have mass into acceleration towards downward direction. So this is opposite direction. You will have mass is 6 kg, acceleration is AB. Right? So parallel to your TAB. Right? So in that case, you have a force here, downward direction, which is 6 AB. Okay. So if I look here, so I don't need to worry about sigma fx here because fx is only having RB. So you don't have to identify because you don't have any friction force. Directly we can go for Fy and we will equate it to 0. So we consider Fy, so TAB, right, minus 6AB, right? So minus bringing to the side. So what will get 58.86 sine 20 degree is equal to 0. So in that case, what I will get? I will get TAB minus 6AB. So you are getting 20.13. So 20.13, equation 2. Now you can easily solve these two equations. You know that. So as usual, if this block is moving 1 mm, this will also move in 1 mm, 1 mm direction. Right. So which means there is no, you can say that your SCA is equal to SB, VA is equal to VB, and AA is equal to AB. Right. So it means I can equate it as a single equation. Right. So the first equation is this, right, which is TAB plus 10 A 10 AB. I'll put it as AB is equal to 45.09. Right. So all this, find out what is your TAB and what is your AB.
29.49, sir.
So 29.49. Okay, good. So what is your AB?
1.56.
1.56 meter per second square. Right? Any doubt in this particular problem? Still, we are not completed. So the question they asked us to identify velocity. Right? Tension we identified, but velocity. So we have identified only your acceleration. So what I can do, I can use a formula. So what formula we can use? So which one we can use for this particular problem? So they need velocity. So velocity will differ, right? It purely depends on your time, right? So the data for time is not given, right? So in this problem, they are not mention anything as a time because we can able to see when your acceleration is a value, which means your velocity is increasing slowly, right? So which means I can't justify what is my velocity without knowing a time, right? So you can assume something. If you have something like this, you can assume. If you have a problem like this without showing what is the value of t, right? So you have to assume in different category. So I am changing my seconds from 1, 2, 3, 4, and 5. Okay. So I have only one formula which I can use, which is v is equal to u plus at. Right. Initially, your velocity is 0 plus 1.56 into t. This is my formula. Right. So you make a table. Okay. So what you'll get? So if t is equal to 1, 2, 3, 4, 5. Right. So what will get? So if t is equal to 1, You will get 1.56. T is equal to 2. 1.56 into 2. So it is 3.12. So T is equal to 3. 1.56 into 3. You get 4.68. And if you have 4, you are getting 6.24. And if you have 5, you are getting 7.8. So not more than this. That is enough. So after you do this, you have to plot, right? You just make a graph like arrangement. Okay. You put t in x-axis and velocity in y-axis. Okay. So I'll just put 1, 2, 3, 4, 5, 6. So I'm going to increase it in terms of twos. 2, 4, 6, 8. Right. So I think 10. That is enough. So here I can put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So just plot it, right? So at 1, it is 1.56. It is somewhere here in this location. At 2, it is 3.2. Sorry, 3.2 is somewhere here. 3, it is 4.68. It is somewhere here. 4, it is 6.24. Of course, I think you will get us a linear velocity. So 4 is 6.24 and 5 is 7.8. Right? So you just plot it, you will get a graph. So something like this, something like a inclined line. That's it, right? So just plot it. That's enough. So you don't go for more than this. So only 4 or 5 readings is enough, right? So this is how you can able to identify what is my velocities according to this particular category, work energy method. Right, according to this, again there is no change. I am going to consider the same block. So the thing is, here you don't have this acceleration, right? Here you don't have this acceleration. So here also I will erase this. Okay, and look at the direction. As I told you, it is moving like this. So this is positive x, right? This is negative x, right? Positive x, negative x. So when I consider here, this is positive, this is negative. Okay, so what I can do, I can identify what is sigma fx, right? Fx is enough in this case because we are concentrating only on tab, not on ra, right? Sigma fx, let us identify what is the value, right? Because fy will be 0. There is no friction force, so no need to worry. So sigma fx, let us identify. If I identify sigma fx, so you'll get 98.1 sine 30 minus tab. This is my sigma fx, which means 49.05 minus tab. This is my sigma fx. Now I can identify what is my work done. Work done is 49.05 minus tab into your distance. Distance is SA, right? So I will directly equate. So you know that work done is equal to energy. So energy we have only kinetic energy. So which is I will get 49.05 minus TAB into SA is equal to half into 10 VA square, right? So which means 49.05 minus TAB SA is equal to 5 VA square. And we consider this as equation 3. So this part is over. Let me go for the next part, which is for B. So the difference is you don't have this, right? Similarly, this one you don't have. So, and you know that this is positive one. So this is positive, right? And this is negative, which means this plus, of course, it is normal. So positive and negative, right? So I'm concentrating again on sigma fx alone. Sorry, sigma fy alone in this case. Sigma fy. So sigma fy is TAB minus, so 58.86 sine 20, right? So 58.86 sine 20, which is 20.13. So TAB minus 20.13. This is my sigma Fy. Again, I can equate it. So I can identify what is my work done. So TAB minus 20.13 SB. And I can also identify what is my energy. I'll put it as a one step. So no need to repeat it again. CAB minus 20.13 SB is equal to energy is half mv square. M is 6. So 6 by 2 is 3. 3 VB square. Equation 4. So what I can do, I can just divide this. So 4 divided by 3, right? So of course EVB, VSA, you can cancel all these things. You'll get a formula, you will get a relation. So TAB minus 20.13 divided by 49.05 minus TAB is equal to 3 by 5. Okay. So what is the value of TAB? Yes, try it out. Next, I am going to substitute this. So TAB minus 20.13. I am substituting in equation 4. Okay. So SB is equal to 3VB square. Right. So what are you getting? So 29.36. SB is equal to 3VB square. So which means SB is equal to 3 divided by 9.36. 0.3205 VB square. This is equation number 5. Any doubt up to this?
No, sir.
Okay. So the next step, what you are going to do is you have to identify what you can do. You can substitute in the equation, right? Right. T and all I don't know. So only thing is I can apply in this equation, right? So second equation, first equation I can apply. So in that case, B square is B square is equal to 0 plus 2 into A into 0.3205 VB square. Right? Again, you will get what is your A value. Yeah. So then there is no other change. Again, you have to make this as a graph and you have to plot it. Okay. So for any method, you will get the same thing. So even for impulse momentum, right? So we can try for impulse momentum also. I'm going to complete it in one step. So we know that impulse is F into T and momentum is M into V, right? I'll complete in one step directly, right? Because sigma Fy, Fx, whatever we identify is same, right? So we're going to use that one and we are going to consider. If I consider A, right, what equation I will get? I will identify this one, right? So I will highlight it. So this one I have to consider. Okay. So if I want to consider this, so which means 49.05 minus TAB, right? So that one I will consider here. So 49.05 minus TAB into T is your impulse. Momentum is M, mass is 10 and V is VA, right? TA VA, right? This is my equation 6. Okay. So if I consider B, which one I have to consider? I have to consider sigma Fi, this equation. This one I have to consider. So TAB minus 20.13, right? So which means I will write it again here. So this B is equal to TAB minus 20.13 impulse TB is equal to momentum 6 VB, equation 7. So as usual, you divide these two equations, you'll get 49. So 6 divided by 7, 10 by 6. Same thing, if you solve, you'll get, you come to this category, this location, right? So whatever you do here, right? Whatever you do here, that will be here. That is what we have come. So we have come to this location. So automatically you'll get what is your TAB and you can substitute it, right? Any doubt in this part,
No, sir.
right? So to solve that type of problem, we need to know how to identify your uh, velocity, acceleration, and distance movement, right? We discussed already. We say that if I consider an inclined block, so something like this, we discuss what we discuss. If I move this 1 mm, what happens to this? So this is also moving in 1 mm. So we discussed that, right? So that is for simple cases which you can directly identify, right? But if you have a complicated like this, some complications, right? So in that case, how to identify, right? What will be the movement of your blocks, right? So for that only I have taken this. Okay. So what you have to do is, first thing is I have to create a datum plane. So datum plane is something. So it is, you identify whichever is constant so that you can eliminate it. Okay. So whichever you can mark, you can able to see this in red color. It is not required, right? So whatever which is wound, which is because always the thread will be wounded here, which will have same length, right? So again, this would also be having a same length, and this hanging is also having a same length. Okay, so no need to worry about these things. Whatever, similarly, this red, no need to worry about it, right? So the best way to identify that is identifying the length of your thread. Okay, by considering a datum plane. I consider a datum plane here. Okay, so I want to identify what is my length of my thread, right? What is my length? So in terms of this, so you know that if I consider datum plane, right, I am marking it. So the distance with respect to block B, it is as SB, right? And the distance with respect to this point to your the other point of your pulley, I will consider something as H, right? And then the distance between this block, right? So the movement with respect to this, from this pulley to this, I will consider as SA, right? When I consider, I can identify what is my length. Length is, look here. So you have 1 SB moving here. This is 2 SB. So I can write 2 SB, right? Plus H plus SA, right? Neglecting these things, even that other things are you can add as a constant. Doesn't matter. Any doubt on this?
No, sir.
So I got what is my length. So length is equal to 2SB plus H plus SA. So now you look here. So which are the things which is variable and which are the constants, right? So when you consider here, your SB is a variable, right? Variable means if this block is moving, your SB value will change, right? If it is 10 mm, when this block moves a little bit, so this will not be 10 mm, this will be 11 mm. So which is a variable. So this is a variable. What about H? What about your H? Is it a variable or
Constant,
a
sir.
constant? Yeah, it's a constant, right? It's a constant because there is whatever may be, this value will be same, right? It's a constant. What about SA?
Variables.
Yeah, very good. It's a variable, right? It's a variable. So you have two variables and one constant that you have to identify. Now you just differentiate this, right? You just differentiate this with respect to time, d by dt. right? So length is always a constant. Okay, so this is also a constant value. Why it is constant? The length is same. Length of the rope is always same. So even if you move the block, the length will be same. So d by dt, differentiation of this, what happens? That will become 0 for your length is equal to 2 yes sb. So if you differentiate with respect to time, you will get vb, velocity. This one is 0 plus this one we get va. So what I will get our answer like this. So va is equal to minus 2 vb. Right? We will get that va is equal to minus 2 vb. What it means is, if your block A is moving at 1 meter per second, your block B will move at 2 meter per second. Multiplied by 2. Negative indicates opposite direction. That's it. Right? Negative indicates opposite direction. For example, if I move this along this direction, this will go up. Right? When I move this downward, this will go along this direction. That's what it indicates, the negative. Right? Negative doesn't matter. So, but this thing you have to remember. So, what about your VA? So, VA is 2 times your VB. Similarly, if I differentiate again with respect to your time, what will get? I will get AA is equal to minus 2AB. Right? Your acceleration is twice your acceleration for block B. So, this is the way you have to identify, right, what will be your accelerations with respect to the different positions. Right? So, we will stop here.